Hello, welcome to the Autism Research Coalition. I'm Patricia Lemmer, the author of Outsmarting Autism, and our guest today is Dr. James Adams. Hi, Dr. Adams.
Hi, Patricia.
How are you today?
Very well, thanks.
Wonderful. You've been on with us several times, and we love you. We're so excited about your research. You're such a wonderful friend to the autism community. And I doubt if there's anybody listening who doesn't know you, but if there is, I'm going to just give a little bit of a background of who you are and what you've been up to lately. So, you're the director of the Autism Asperger's Research Program at Arizona State University, ASU, and you work with doctors, nutritionists, biochemists, and with your research focused on some of the underlying causes and treatment of autism at all ages. And Dr. Adams believes that the addition of this biomedical research to treat individuals with autism is really important to improve the effectiveness of the other therapies that these kids are getting educationally, behaviorally, psychologically. So Dr. Adams is a PhD, not an MD, and he went somehow from materials engineering to biomed autism, and he's published, would you believe, over 200 peer-reviewed scientific articles, including 50 on autism. And lately, he's been looking at the gut and at the microbiome and at microbiota transplant therapy. And this is what he's going to talk about today and how he is working to get this out there for our patients and our family members. So, Dr. Adams, take it away. This is so exciting for us to have you.
Well, thanks very much, Patricia. So what I've been asked to do is give a brief 5-minute summary of our previous work on children with autism, treating them with microbiota transplant. Then I'm going to spend most of the time talking about new results I've shared in only one small conference before, and this is on our study of children with Pitt Hopkins, which is a form of severe autism. I do this work closely with my collaborator, Rosie Krajmalnik-Brown. And for the Pitt Hopkins work, we had a particular study physician, Dr. Robert Helmers, who helped us with this, as well as many other staff on our group. Again, brief disclosure, I have patents pending and approved for FMT or in probiotics, as do my collaborators for autism, Pitt Hopkins, and other conditions. We have funding from Finch Therapeutics for consulting, for research. I want to emphasize MTT is an investigational treatment. It's not approved by the FDA for autism or for any condition yet, but we're working on that. I have formed a new company, or I'm in the process of it, which will be a new company developing MTT for Pitt Hopkins. And I'm also part owner of another spinoff from ASU, Autism Diagnostics, focusing on investigating what's different in the metabolism of children and adults with autism. So very briefly, 20 years ago, Dr. Sandler did a study with others, and they found that vancomycin, a very potent antibiotic that stays in the gut, led to great temporary improvements in gut symptoms and autism symptoms. But unfortunately, although there's a big improvement, so a positive score here shows a big improvement, after treatment was stopped, within a few weeks, even though many of the kids took standard probiotics, they lost almost all their benefit. So we assume that the bad bacteria, which the vancomycin killed off, returned. And probably a variety, our guess is a variety of harmful bacteria. And so we published a study 10 years ago showing quite strikingly that children with autism who had gut problems, those shown in red, had much worse autism symptoms than the children with autism who did not have gut problems, shown in blue. So if you had gut problems, you had worse speech issues, social issues, sensory and cognitive issues, and physical and behavioral problems. So our hope is if we can treat those gut problems, we can reduce those red bars down to blue bars and really improve symptoms. Some of our studies have consistently found lower microbiota diversity in kids with autism. Most people have about 1,000 species of gut bacteria. We found in our studies that kids with autism are missing several hundred. But the complication is one child is missing these several hundred, another child is missing that several hundred. There's a lot of difference. There's a lot of disagreement in the research community are what is different about the gut bacteria in kids with autism. So over 30 studies of microbiota, very little agreement on which bacteria are different. There are 7 studies showing increased levels of 3 pathogenic bacteria, C. perfringens, C. histolyticum, and C. bolteae. It appears that kids with autism, my interpretation of all of these studies is that kids with autism have very wide variations in their gut bacteria, but often have one or more pathogens and lack many beneficial bacteria. So the treatment implications is you'd like to use a broad spectrum probiotic, but commercial probiotics contain only a few bacteria, not the ones needed by kids with autism. So it suggests fecal transplant would be needed. FMT is used very widely for C. diff. It has helped tens of thousands of people, but C. diff is very easy to treat. One dose, one time, 90% cure rate in a few days. Autism, it turns out, is much harder to treat. I'm going to jump through a few slides. We did a study where we used a much more intensive therapy that we call microbiota transplant therapy, which involves 2 weeks of that special antibiotic, or vancomycin, which we give orally, and then a day of fasting and a bowel cleanse to remove any remaining gut bacteria, and then high dose microbiota, and then followed by low dose. And we get the microbiota from very carefully screened donors. So it's essentially a super probiotic with 1,000+ types of bacteria from super healthy people, the top 5 to 10% of the US population. Most people don't meet our very strict qualifying criteria. So we treated 18 children with autism. I'm going to skip over some of the initial issues. We had an 80% reduction in GI symptoms, and we waited and stopped treatment. And 8 weeks later, unlike with only Vanco, those benefits remained. Also, we saw initially some improvement in autism symptoms at the end of treatment, and those benefits remained 8 weeks after stopping treatment, and there is improvement in the microbiome diversity. But then we did a follow-up study 2 years later, and what we found is that most of the GI improvements remained 2 years later, and the autism symptoms just continued to seem a slow, steady, gradual improvement. Parents generally reported their children were just better able to learn language and behavior and social interaction. This is an open label study, so there's some placebo effect, but it was very promising. So based on that, we are now working on what are called phase 2 studies. So that first study was a phase 1 study, which the FDA requires to demonstrate safety. We also found it demonstrated some good indications of efficacy. So the FDA granted us fast track status and allowed us to go on to do phase 2 studies, which we're doing now. And if those studies are successful, then we would still need to do phase 3 studies, 10 times as large, 10 times the cost. So we've just finished the treatment portion of our adult study with Dr. Richard Fry. We're now doing long-term follow-up on those participants. We're now analyzing the results. We have our child study, which we're enrolling the last people in treatment over the next couple months. And what I'm going to focus on today is our small study for children with Pitt Hopkins. And many people have helped with this, so I just want to emphasize that. So I want to turn now, and I'm going to go a little bit slower because this is the new part, to a very rare single gene disorder called Pitt Hopkins syndrome. It's a neurodevelopmental disorder that's caused by a mutation or deletion of a particular gene. It's extremely rare. We only know of about 500 people in the US, mostly children, because the genetic test was only available recently. Children with Pitt Hopkins, there's some variation, but generally they have very severe autism, very limited language, very limited social interaction, and many of them just cannot speak. Also, often very severe intellectual disability, often functioning at the level of about a 2-year-old, and also very physically disabled. Many of them have very limited gross and fine motor function. Many of them need walkers or wheelchairs to get around. Also, they suffer from very severe chronic constipation in most cases, partly perhaps due to impaired muscle control that you need to be able to force food down through the intestines and out. So these kids have a lot of complications. This is a single gene disorder. And the question is, can we treat just a part of that? Can we treat the chronic constipation? So this is a quote from the director of the Pitt Hopkins Research Foundation. She's a parent of a child with Pitt Hopkins. And she says GI pain is the major factor in the quality of life for these kids. The children with Pitt Hopkins are often in a great deal of abdominal pain. For example, my son has daily pain. I can tell because he's agitated and sometimes cries because of it. Some children with Pitt Hopkins wind up in the hospital because they're in so much pain. When my son has a bowel movement, the pain decreases, but it can return within a couple of hours depending on how severe it is. Most of our parents would say whenever their child seems uncomfortable or upset, the gut is the first thing to look at. Again, these kids often have very limited language, and so it can be difficult to assess their pain. But it does seem to be a major issue for them. So we already discussed a little bit. I'll just say again, FMT is widely used for C. diff infections. C. diff infections used to cause about 500,000 infections a year in the US alone, and used to kill about 29,000 Americans a year. Can be treated with antibiotics, but it often returns. And so FMT has been found to cure C. diff, and unlike with using antibiotics, it's unheard of for a C. diff infection to reoccur once you've had FMT. It seems to be very long lasting. So FMT has now been used by hundreds of hospitals to treat over 50,000 people with C. diff. It's not yet approved by the FDA, but they're allowing it for C. diff only because it's just miraculous. But because it's not approved by the FDA, it's only allowed. That means no one else can use it off-label. But phase 3 trials are underway of it for C. diff. We hope it will become approved at some point. So why do we want to consider MTT for children with Pitt Hopkins? Well, there are several reasons. First of all, we published a study led by my collaborators at the American Gut Project, where on the left we see the diversity of gut bacteria in kids with autism. On the right, in the middle, we see the diversity of kids with, the left is kids with Pitt Hopkins, the middle is kids with autism. Their diversity is a little bit higher than that of kids with Pitt Hopkins. And then on the right, we see typical children, and their diversity is a little bit higher than that of the autism group. So the kids with Pitt Hopkins have even worse diversity than the kids with autism, and they also have chronic constipation. So those two reasons alone be very compelling. But we also showed in this paper that we published last fall, that the kids with Pitt Hopkins have a very high level of a nasty cousin of C. diff called Clostridium bolteae. This is, oddly enough, a bacteria that was discovered in children with autism and named after a mother of a child with autism because it was only found in kids with autism. And so this is a log scale. And what this is showing is that children with Pitt Hopkins, most of them has orders of magnitude, to hundreds, thousands, tens of thousands times higher level of C. bolteae than their parents do. So it makes us very suspicious that this is a big problem contributing to their symptoms. But we don't know a lot about C. bolteae. It's a suspected pathogen, but again, we don't know a lot about its function of action. A nice quote I've heard people make is we know more about the stars in the universe than we do about the bacteria in our guts. There's still a lot to learn about our gut bacteria. So anyways, we went ahead and proposed to the FDA, and they approved us to do a clinical trial of MTT for Pitt Hopkins for the reasons I just mentioned. This has generated great excitement in the Pitt Hopkins community because it's the first clinical trial ever done for children with Pitt Hopkins. And we want to thank the Pitt Hopkins Research Foundation, which is basically the parents, very much for funding this study. So this study was very similar in design to our other studies. Part 1 is a randomized, double-blind, placebo-controlled trial. Half get the real treatment, half get placebo. Then in Part 2, the placebo group is switched to the real treatment, and the treatment group is just observed. And then in Part 3, we do another 3-month of observation. We didn't do a long 2-year observation because we were impatient. We wanted to know. The real concern is because these children with Pitt Hopkins have weak muscle control, and also because they have very low physical activity. Just a low physical activity alone could contribute to their symptoms. Excuse me just a second. Okay, so the question is, after we treat them, we might be able to wipe out the bad bacteria, but then because of their low physical activity, because of their low muscles, would they revert back to constipation after treatment? Would the benefits be only temporary? So our treatment is very similar to that for autism. 10 days of vanco instead of 14, because we didn't know at the time when we planned it what was present in their guts. We gave them 1 day of a bowel cleanse, really half day, and a half day of fasting with that. And then we gave them the microbiota capsules. We did a little longer treatment for them, 3 months. We also gave the treatment a little more gradually, a high dose over 2 days rather than 4 days, because we're giving a lot of pills during those first few days. The study uses a capsule form, and these are children, and we were worried they would have trouble swallowing so many pills. So high dose for many days, and then a lower maintenance dose. The participants, we plan to start with 10 children with Pitt Hopkins and grow to 20. But remember, there's only 500 known cases in the US. Unfortunately, we were only able to enroll 7 children because we discovered that unfortunately most children with Pitt Hopkins are so physically and mentally challenged they were not able to swallow pills. So we also had one dropout who after the first few days we realized they could not swallow pills consistently. They could swallow a pill, but they could not swallow pills consistently. So they dropped out in the first few days, and we had 6 participants who completed the entire study. This is a small study. I want to emphasize that. So we have to be cautious in interpreting the results. We had 3 participants randomized to Group A and 3 randomized to Group B. So because this is a small study, I'll show you results that are suggestive, but mostly not statistically significant, although a few are. So I'll share that. So if we look at GI symptoms, this is using the GSRS, which asks about 15 different GI symptoms. So we're averaging over 15 symptoms. A 1 means 0 symptoms, and it goes up to 7 being the maximum. These kids had pretty severe symptoms, average scores of 4 to 4.5, averaging over 15 different GI symptoms. That's at baseline. Then what we see is at the end of part 1, the treatment group, shown in blue, had a big reduction, 80% reduction of their GI symptoms. The placebo group, shown in orange, had some reduction of their symptoms, 30%. And that's what we call placebo effect. In particular with GI studies, there tends to be a high placebo effect. And for this study, the first study ever done for Pitt Hopkins, you have to expect there would be some placebo effect. So anyways, then in part 2, the placebo group was then switched to treatment, and we see they also had a big reduction in their GI symptoms as well. And then we followed both groups for another 3 months, and to our pleasant surprise, we saw those GI benefits were continuing. They did not lose GI benefits, even though the children were still on the same diets. They were still physically having little physical activity, and they still had weak muscles. So overall, looking at part 3, compared to baseline, there was an 84% reduction, averaging over 15 GI symptoms, and that's very statistically significant. That's very exciting. If we look at the 5 subscales of the GSRS, if we look at abdominal pain, there was a big decrease here in the treatment group. And then when the placebo group was treated, their pain disappeared as well, and then stayed very low. This again was the biggest issue for the parents, to see their children no longer in such severe pain. Sorry if I get a little teary-eyed thinking about this. Oddly enough, for reflux, it's not so common in kids with autism or in kids with Pitt Hopkins. By random chance, the placebo group had reflux. They had some reduction during placebo, a lot more improvement after treatment. But the autism group, the treatment group, original treatment group, didn't have reflux, so it didn't change. Diarrhea symptoms, these kids were all on heavy laxatives as well. They needed that every day, otherwise they would be hospitalized due to impaction. And so they also had some soft stools and diarrhea. The treatment group had almost total reduction of those symptoms. The placebo group, small change until they were treated. And those benefits were long-lasting. Indigestion issues, stomach upset, heartburn, etc. These also improved more in the treatment group than placebo group. And then constipation, the thing that was the biggest concern for all of them, went from a 6 down to 1.5 in the treatment group, and then again continued very minimally in the treatment group, and substantially improved in the placebo group that continued with treatment, but still had some lingering symptoms. Now we're going to move on to the pain scale. This is a special pain scale developed for children who have very limited verbal ability. So the parents observe 5 symptoms, which is given by this acronym. They observe the child's face, they observe their legs, the child's activity level, the level of crying of the children, and the level of consolability of the child. So they look at 5 different symptoms on a scale of 0 to 10. So these children had a 5. They have constant pain throughout their lives, but it's not absolute pain every moment. Is probably the best way to put it. And so we saw the treatment group improved more than placebo during initial treatment, 71% improvement versus 47%. And then the placebo group improved more when they received the real treatment, and then 3 months later continued. So overall, 79% reduction in this scale. The scale is rather crude because it's scored on a 0, 1, or 2, but very statistically significant reduction in pain according to this scale. Excuse me again for just a moment. Okay, so moving on, we also had to create a special scale to assess the Pitt Hopkins symptoms because there was no scale. So we took our autism scale, which we've used in a number of studies, which has 20 autism symptoms, things like language and social interaction, as well as physical symptoms like GI symptoms, sleep, hyperactivity, irritability, etc. All the major co-occurring symptoms as well. And we added in 9 symptoms that were specific for Pitt Hopkins, symptoms like gross and fine motor function that are problems for them as well. This scale, we ask how much change there is on a scale of +3 is much better, down to -3 is much worse. So we're averaging over 29 symptoms. We see that the treatment group initially gets, you can interpret this as slightly better on roughly a little more than half of the symptoms that they have. And the placebo group has only about half as much improvement. Then when the treatment group is observed, longer term, to our surprise, not only do the benefits maintain, they continue improving. Apparently, our interpretation of this is because the children's pain has gone away, and many parents just say their child is just happier. And we wish we had included a question on happiness, but the parents just said because that pain was gone, they were just happier. And so many other symptoms like biting parents or being aggressive or being irritable, a lot of those improved. And I think if I was in constant pain and that pain was decreased, I'd be a lot happier too. And the placebo group, oddly, when they were switched to treatment, initially there wasn't much change, but then later there was somewhat more improvement as well. So again, we're averaging over 29 symptoms, but in general, we're seeing good improvement in a number of areas. If we look at the single question on the PGI about GI symptoms, now you'll notice on average, the treatment group says slightly better to better, whereas the placebo group says much less improvement. And then later on, when both groups are treated, now they're saying, gee, now they're doing better. And 3 months later, after treatment has stopped, their GI symptoms are still better. So that is very exciting. They're not cured. The GI symptoms are still there, but they're a lot better and bothering them a lot less. And then to look specifically at the other symptoms that improved. This is very interesting. So I mentioned the GI was the biggest improvement, but quite a few other symptoms improved almost as much. Irritability and mood. Again, if you're in less pain, you'd think you'd be less irritable. Their overall symptoms. This is a question about overall, all of their Pitt Hopkins symptoms. Social ability improved. Anxiety improved. Tantrums and meltdowns, rashes, gross motor function, stimming, aggression, receptive language, eye contact, fine motor, expressive language. Now, there were some improvements reported in the other symptoms. None of them got worse, but probably a fair bit of that is placebo effect. So I'll list the others here. I'll just point out the other symptoms all were reported as having improved to some extent, but we think a fair bit of that is probably placebo effect. Finally, we'll look at the daily stool record. For the daily stool record, we over 14 days, we ask how many days are abnormal. Abnormal meaning you either have no stool or the stool is an abnormal hardness, unusually hard or unusually soft. And at the start, almost all of these children are on GI medications, primarily stool softeners or laxatives to help them have a bowel movement because otherwise they'd be very constipated. And most of them continued those medications, but by the end of the study, 4 of the 6 participants greatly reduced or even stopped their GI medications, their laxatives, stool softeners, suppositories. That complicates analysis of the stool record because now they still have some symptoms, but they no longer need those medications or need less of it. So the best way to interpret this is both groups improve, but oddly enough, by the end of part 2, I need to update this for part 3. Again, this is all preliminary data. We see even a little more improvement in group B. And then, so our interpretation of this is that the GSRS on bloating showed a 74% decrease by the end of part 2. So even though the children, due to their extensive laxatives, were having a bowel movement every day, there was still a lot of bloating at baseline. But after treatment, there was a big reduction in their bloating and hence also in their excessive gas that they had. And so probably they were a lot less backed up, and we think that's why they had a lot less pain. If we look at a subset of the daily stool record, this is the number of days of pain. So the treatment group, unfortunately, only 1 of the 3 parents felt they could assess their child's pain on a daily basis. So for 1 child who was having pain 13 out of 14 days, at the end of treatment, they had 0 days of pain, and that continued to be 0 days of pain long term. The placebo group had only a very small reduction in pain while on placebo, and then they had almost no days of pain when they were treated. So bottom line is there was a 97% reduction in the number of days of pain, and that was statistically significant, but based on only 4 participants. The other 2 parents who did not feel they could assess their child's pain on a daily basis, they still said their child's pain assessed on a weekly basis decreased 83% in part 1 and 100% by part 2. So again, we think that the reduction of pain is a really big issue for these children with Pitt Hopkins, where that was really the major factor affecting their quality of life. So to summarize our preliminary results, for the various measures of GI symptoms, of pain, our overview of 29 Pitt Hopkins symptoms and the specific GI symptom, the treatment group improved more than the placebo, and the placebo group improved when treated. And for group A, the benefits remained 3 months after stopping treatment. The daily stool record, both groups improved, but the placebo group oddly improved more when they were treated. Again, with just a few participants, we have to expect some variations. But overall, I think the key issue is number of days of pain, which was reduced 97%. There's some placebo effect in there, but still, that's a number I'm very happy with. The microbiome results are still being done. My collaborators have analyzed some of that. I don't have time to present it today, and that's their work. But the exciting thing is this small study, and again, a very small study, found major improvements in GI symptoms and pain, and some improvements in Pitt Hopkins. The question is this enough improvement for FDA approval? So the FDA has some very odd rules, some very special rules for when you're dealing with very rare disorders like Pitt Hopkins. Normally, you have to go through phase 1, phase 2, and phase 3 studies. But if you have an extremely rare disorder like Pitt Hopkins, they generally only require a small study. Generally, the example they give is if you see improvement in 3 out of 12 children, that's enough for drug approval. Well, we saw improvement in roughly 5 out of 6 children. You could argue it's 6 out of 6, but I'll be conservative and say 5 out of 6. Is 5 out of 6 better than 3 out of 12? If we did another 6 kids and saw no improvement, we'd still be at 5 out of 12. So it's good, but it's a small number. So it's probably not enough for drug approval. So now we're working on creating a liquid version of our supplement, and we hope to redo this study with children with Pitt Hopkins and redo that with 12 to 15 people. And we hope that small study might be enough for drug approval for children with Pitt Hopkins. So we do need to raise quite a bit of money for that. The Pitt Hopkins Foundation, this is more than their total annual budget, and they're funding many other small studies as well. They've already given us a grant that was much larger than any other grant they've given before because clinical trials are expensive, but we're going to be trying to raise this money in the next few months. Forgive me if I get a little emotional. It's just so exciting to see this. So we really want to thank the Pitt Hopkins Foundation for funding this research. Many thanks to the families. These families have very challenging children who they love very much, and it was very powerful to work with them. And many thanks to our research team, including Dr. Crouch Malnick-Brown and our study coordinators, and the group at University of Minnesota for providing the Microbiota capsules. Forgive me again for just a moment.
This is very, very exciting to hear, and I can't wait to ask a few questions of Dr. Adams on whether or not what it looks like going forward. Dr. Adams, are you finished with the presentation?
I'm done. So I'm
Good.
ready to take any questions.
So I have a couple questions. We know that the incidence of autism is higher in boys than in girls. Are you seeing more males or any females in your study?
Yes, we had some females in the study. I'm cursed with a terrible memory, so I can't recall the exact number off the top of my head, so I apologize.
But you had at least one.
Yes, two,
Uh-huh.
I believe.
And did you look at any gender differences?
We can't with so few children involved.
Right, right,
Um,
right.
so I can't make any assessment of gender.
So, of course, when we come up with these new genetic syndromes, I always wonder about what caused the mutation in this gene. Has there been any study in looking at, did this subgroup of autism always exist, or is this something related to some environmental assault? Or
Yeah, the genetic test for this became available only about 15 years ago, when they were able to really to pin down and identify this, the genetics of it. Prior to that, they were aware of the syndrome, and these children have very specific symptoms in addition to autism. Not all of them necessarily have a diagnosis of autism, but again, many of them do. So it's distinct from autism, but has a lot of overlap with severe autism, coupled with severe physical issues. But in terms of the genetics, um, I'm trying to remember offhand. I believe this is often a de novo disorder, but again, I have to double check my notes on that.
And has anybody who's doing any of the nutrigenetics tried to repair this gene?
There are a number of studies going on right now to look at the genetics and see what can be done with gene transfer and other therapies. Those studies are still underway in mice or even in cell cultures. So it's going to be a while before they're brought for humans. There's a lot of safety issues to look at. Again, I want to emphasize our treatment is just able to treat the constipation side of things, but we were surprised to see how much that led to improvement in quality of life in a variety of other symptoms. I mean, one child I remember was able to walk much better. First time they could walk 10 feet in their life. So they were, just big improvements there in some children in some areas. But still, they have this underlying genetic syndrome, which affected their development early on and continued. There are multiple types of interventions that are being investigated for Pitt Hopkins. Can you replace the function of the gene with the proteins that are made? Well, if you could, when would you give it? Would you give it during pregnancy, infancy, etc.?
Right.
There's a lot to learn. There is a lot of exciting research the Pitt Hopkins Foundation is funding in this area. Our work is just on what seems to be one of the most pressing quality of life needs.
So I'm fascinated by the presence of low tone in this population. And since the bowel is basically one giant muscle, it's
Yep.
it's not surprising that we have all these bowel symptoms. Um, have
Absolutely. And I
Yeah,
think that's coupled with the very low physical activity level. I
right.
mean, again, many of these children are in wheelchairs, or even when they're out of the wheelchair briefly, the amount of walking they're doing, 10 steps might be a huge amount for a child.
Has there been any attempt to do any kind of passive movement muscle to improve tone?
Yes, these children are generally receiving physical therapy quite intensively, and that's something they were continuing during the study. But there were no changes in the therapies. We did not allow any changes in therapies, medications, supplements, or diets during the study. But yes, occupational physical therapy, these are speech therapy, are important issues for these children.
So you now have kind of a fingerprint of this Pitt Hopkins subgroup, of what their microbiome looks like. I've read, thanks to Enrique, some studies that are generalizing this and taking it to fingerprints for various kind of cancers and for MS and Parkinson's and um, mental illness. is this a study that then can be used as a template for some other diseases?
Well, I'd step back a moment first and talk about its relationship to autism, that the C. bolteae that we found to be very high in the children with autism, and also one of the other, there are 3 Clostridia that have been consistently found in half a dozen studies to be higher on average in kids with autism, and that includes C. bolteae as well as 2 of its other nasty cousins, C. perfringens and C. histolyticum. And so seeing that these children with Pitt Hopkins in general have very high levels of C. bolteae, and seeing that our treatment really resulted in great improvements. We don't have all the microbiome data yet. And again, our microbiome data is limited using 16S. We didn't have the funding to do full metagenomics. So we can't necessarily get down to the species level. But still, I think seeing that we are able to treat a condition very much associated with C. bolteae, and that's one of the 3 bacteria very suspicious in autism. And in fact, C. bolteae is named after being discovered in children with autism. I think this certainly suggests this treatment would help the children with autism who have C. bolteae, and likely its cousins. Going a step beyond there, as you were asking, this general treatment, I think the general concept of MTT could be used to help a wide range of GI disorders, but you might need a different pre-treatment. We pre-treated with vancomycin because that's been shown to be effective against these Clostridial species, but it also affects a number of other bacteria. But if you had a different gut infection or a fungal infection, you might need a different pre-treatment. But then the concept of then following that with a bowel cleanse and then microbiota capsules, I think would still make very good sense. So even for fungal treatment, which is again an area I'm very interested in, I think there's good evidence, well, there is good evidence, several studies, including ours, showing about 25 to 50% of kids with autism also have chronic fungal infections, yeast infections that are affecting their intellectual functioning. I think that's an important area as well. But moving on to other areas, I think many people with anxiety and depression could be that is growing evidence that can be related to GI issues. With Parkinson's, it's fascinating that GI symptoms occur usually 20 years, chronic constipation 20 years before the Parkinson's symptoms occur, and perhaps Alzheimer's and other conditions. So as I mentioned, it's so frustrating to me. We know more about the solar system and the stars than we do about the bacteria in our gut. We have many bacteria in our gut. We have little idea what their function is. And are they pathogens or good guys? Or really the issue, I think, is what's the balance? If you had only one bacteria in your gut, even if it's a good one, I think that would be very unhealthy. So we really, our focus is trying to restore balance. We think the best way to do that is to give bacteria from very healthy, very, very healthy donors. So that was kind of a long-winded answer. I apologize, but I
love it.
hope that answers.
It takes me to the next question. How do you screen your donors? How do you know that this person has a healthy gut? By the diversity, by the lack of bad guys? What do you do?
Yeah. So there's a protocol established by the American Gastroenterological Society. I may have the name slightly wrong, but basically you start with the requirements for blood donors, and that the Red Cross, for example, would use. So you check to see they don't have any active infections or at risk of any, and then you go beyond there to check for GI symptoms in the individual. In some cases, even checking for GI symptoms in their family, like are their parents at risk of a GI cancer. Then you check for their body weight. We think body weight is very much affected by your gut bacteria and vice versa. And so we check to see that people have an ideal body weight. That rules out a lot of Americans. And then also doing screening of the stool samples themselves for a wide variety of pathogens. And then also checking after the donation, we continue to follow the donors and make sure they weren't just coming down with some symptom. And nowadays, of course, we also check for SARS-CoV-2 in the donors. So that's a short summary of what we do.
Very
But,
interesting.
yeah.
So
And that's all done by our colleagues at University of Minnesota, who I just have to applaud for their work.
there's a question on the use of rifaximin. I don't know if I'm saying that right. If
Yeah.
As a pre-treatment, or are you familiar with that?
I'm roughly familiar with it. We've never used it in our studies. It's used for SIBO, as I recall. It's intriguing. There are certainly physicians using that for treating individuals with autism. I would like to see research studies on it for autism. I haven't seen any research studies yet, and I don't have any clinical experience with it. So I'm going to say it's intriguing, and would be very worthwhile to do a research study on.
Yeah. So there's several questions on families who want to become part of your study. Can you comment on that?
Yeah, unfortunately, I get emails every day, and it just breaks my heart that families want to be part of our studies. And we do have on our website a sign-up list, and I have an email list. I send out emails when we have updates on our studies. But right now, we're finishing up our adult study for autism. We're just enrolling the last people for a child MTT study. I want to thank the Achieving Cures Together group that just gave us a little extra funding so we could recruit the last people for that. Finch Therapeutics is planning a small series of phase 2 studies coming up probably towards the end of this year. And I'll certainly be happy to announce that information when it's available. And we are doing our probiotic study right now. And we are submitting a grant request to do a study of yeast in kids with autism, just to evaluate yeast, because I think that's a very big overlooked area. We would love to do a yeast study if we had funding for that, but we don't at the moment. At the moment, we don't have any other openings other than our probiotic study with Sun Genomics, but we hope to have, if our phase 2 studies, if our current phase 2 studies are successful, then we'll try to work with Finch Therapeutics to raise funds for phase 3 studies, but those are very expensive. We're talking 500 people, maybe $50 million or more. Finch will need some big investors to do that.
We sure do. So there's a question about whether you check your donors for the bugs that are associated with Lyme, the Borrelia and Bartonella.
It's an interesting question. I don't think we do, but I'll have to check and see. That's a good question, actually. Because we're transferring the gut bacteria, even if someone had Lyme, well, I would rather not use them as a donor. It's an interesting point. Our donors come from Minnesota, where Lyme disease, I believe, is relatively rare, but not, it still exists everywhere in the country. That's a good question. I'll ask. Thank you. It's a very good question.
Okay. And I'm fascinated by your comment that.
But I should point out too, though, that we do check our donors to make sure they're in very good physical health. So generally, people with Lyme disease are not.
Right. Yeah. So the body weight, the relationship between body weight and gut bacteria. I've seen studies that mouse studies where they give fat mice bacteria from thin mice and they lose weight, and thin mice bacteria from fat mice and they get fat.
Right. And that hasn't been replicated to my knowledge in humans. So it may be more complicated in humans, but it's certainly a concern. And that's why we do strive for ideal body weight. There are also some interesting mouse studies showing that if you take gut bacteria from younger mice and put them in older, they appear younger. Unfortunately, the reverse is true. So it does make us think we want to use gut bacteria from young, healthy donors.
Yeah. So are you going to be at any of the upcoming fall conferences with your?
Yeah, I'm speaking at several. I'm speaking at the Autism Society of Greater Phoenix. I've been the president of it for 20 years, so I better present there.
Right.
Autism One, MAPS, TACA. Those are the ones that come to mind offhand.
And the dates for those, are they on your website?
No, you'll have to go to the individual sites for
Okay.
those.
But if people want to stay in touch with you, what is the actual website? Enrique can put it in the banner again.
Yeah, it's just autism.asu.edu.
And they can sign up for your newsletter.
For our email list, yeah.
For your email list. And then they'll be updated. And if they have filled out an application, as some of them have, to be part of future studies, you keep
We aren't allowed to receive applications for studies until the study is approved. We can allow people to be on an email list. So it's just FDA rules. We can't advertise a study until it's approved. So we can't receive applications, but we can receive, but people can be on our email list. Also, of course, we're working towards trying to get compassionate care approved, and we will continue to strive towards that. The FDA told us not yet. They want to see more data, and we're working hard to generate that data. And I want to also thank, all the families who participated in our studies, and also all the 1,000+ families who've donated to our research. Without their support, we wouldn't even have a child MTT study. So we really want to thank everyone who's helped us.
So obviously the pill route wasn't the ideal way to get these critters in, and so you said you're now doing a liquid.
Yeah, the liquid should work fine. Yeah, unfortunately, when we did the study, no one told me that the Pitt Hopkins kids couldn't swallow pills, and I just assumed they could. So that was unfortunate. If we'd known that, we could have used a liquid, and we would have, as we did in our first autism study, and then we'd be submitting for approval if everything went well. So sometimes you learn things as you go along.
What will the carrier be?
What will the carrier be in the liquid?
Yeah.
Will actually be a powder that we're developing. And then the powder, like a probiotic, just think of it as a probiotic powder, and then you'll be able to mix it in juice or water or whatever a child likes to drink.
Awesome.
So that should be much easier. That will need to be given with a stomach acid suppressant, because otherwise your stomach acid would kill off almost all the bacteria. That's what happens when you take normal probiotics. They can just be killed off by your stomach acid. One thing I should probably mention too, though, if I may, is just if people want to learn more about the results of our research, we also created an app which is available on autism on iPhones, on Apple, from the Apple App Store. It's called ANRC, so after the name of our nonprofit, ANRC Autism Treatment Radar, and it shares the results from 1,200 families of what they think were beneficial treatments for them, including gut treatment. So people can also go to look there for ideas on what treatments other people in the autism community have used and found were helpful or harmful. See what were the benefits, see what were the adverse effects.
So I love that
Thank you.
There we go. So this is the updated version of Bernie Rimland's what worked, what didn't, and
yeah, Bernie inspired us to do this. Just goes into a lot more detail. Bernie had more people, but we have a lot more people. We have a lot more detail in this survey.
So
I want to thank the 1,200 families. What's that?
It's cumulative. So you're looking over time of yeast protocols or
at the moment, no. This was a static survey that we did, and we've released it. We may do an update later. Actually, I have to be careful what I say. Let's just say that's an active area of future research, is to improve on this with the next generation.
And when will it be available for Android? I'm an Android user.
I was hoping in a few months, but it depends on my code developer, who's a wonderful person, but doing all the work for free. So you have to thank them. And if anyone knows of a good web developer who can help us update our website, I would love that. I need a good web person.
So where can people donate? We've got lots of questions. People want to help you out financially.
We would love that. So let's see. I need to update my ASU website to have that information on it. Unfortunately, we just lost our webmaster. But they can donate to our MTT studies through our GoFundMe page. I don't have the websites handy for our ASU Foundation page for General Foundation, but I can maybe send that out later. I just don't have it handy.
All right, but I think that's what they want to donate to, is to the transplant study.
Yeah, so we have both a GoFundMe page for both our adult study and for our child study.
And where is that, on Facebook?
Well, it's on GoFundMe, and it is also listed on our ASU page. So if you go to our ASU page, it lists currently the GoFundMe. Pretty sure it has the GoFundMe links.
Okay.
I should double check that and see. As I say, we're in the process of working to update our webpage. We just lost our webmaster, so we're not quite ready to do that.
So how do potential webmasters contact you at this same?
Send me an email, jim.adams.
Jim.adams at autism.asu.edu.
At asu.edu. Yeah.
Terrific.
Yeah, and I guess actually we don't, maybe, no, do we have a donate there? Yes, we do have links on the autism.asu.edu page that has general links. Oh, actually it does have a foundation link as well. That may be an old one.
Okay.
But if it doesn't work, just email me. Again, glad to talk with families whenever they have questions.
What are your timelines now? When do you think this might be more generally available to the autism community?
Well, unfortunately, it takes a long time to get drug approval. So we are completing the phase 2 studies for autism. If those studies are successful, and we'll know in a few months for the adult study, although we'll still do the long-term follow-up, then we'll try to raise the money for phase 3 studies. But that's very difficult. As I say, need of order $50 million or more for Finch to do that, because we've licensed our patents to Finch for that. But we'd hope that they'd be willing to do that. But they need of order $50 million. So that's going to be the big showstopper, is getting the money that they need for that.
Why is
but
it
for
so
Pitt Hopkins,
expensive?
there's a much lower barrier. We have to raise about a little over $500,000, about 2/3 million, to do that second study. And then it would be approved, at least for Pitt Hopkins.
And why is it so expensive? Where does the money go?
Yeah. FDA documentation and regulations is a big part of it. You know, every person is overseen in detail. We have to fill out huge amounts of documentation on every single person in the study. And it takes a lot of time to follow them. And then when you go ahead and submit, you then have to have consultants who want hundreds of dollars an hour to review your FDA format to make sure you've dotted all your I's, crossed all your T's. We do our studies on the cheap side. Pharmaceutical trials, it might be 10 million to do a study that we did for $1.5 million. So the FDA is kinder to researcher investigators like myself, but still we have a lot of paperwork and a lot of documentation for each person.
So leave us with some optimistic words, some hopeful words for the use of this transplant procedure for autism. It seems to be almost too good to be true.
Well, I'd say that for Pitt Hopkins, it worked beyond my expectations. I would have been happy if it just gave temporary benefit to just constipation alone. and even just temporary. But it seems that the benefit is long lasting. It's not a cure, but it certainly greatly improves the constipation symptoms. And not surprisingly, by removing a lot of the pain, it seemed to improve a lot of those other symptoms. The children just seemed happier. Does it work as well for autism? We'll see how our phase 2 studies turn out. My sense is the Pitt Hopkins study was especially strong, but we'll find out in our studies as it comes up. So keeping my fingers crossed.
Well, Dr. Adams, you're a rock star for us, for our families, and I know you are personally involved in this. This is something you do out of love for your family and for all the families you work with. So we can't thank you enough for all that you're doing and helping everybody. And thank you for coming on and sharing your findings with us yet again.
Yeah, and thanks very much for hosting too. Very much appreciate that.
Okay. So we keep us posted and stay well.
Thank you. Take
Thank
care.
you. Bye-bye.